Hey, what's up guys? Mr. Flores here, and this video is going to finish complex numbers for us, where we're going to multiply them, we're going to divide them, okay? So, basically, when you multiply complex numbers, you multiply them just like you would really anything else, okay? So, let's say, for instance, we have, I'm going to erase this problem for now. So, let's say we take 3 times 3. Well, we know that's equal to 3 squared, which is equal to 9. Because you multiply anything by itself, you just square it. Okay. So if we multiply x times x, well, that's just equal to x squared. Okay. So, well, when we multiply i's, if you do I times I, we know that's just going to be I squared. Okay. When you talk about imaginary numbers, though, there's a little catch. Because I times I is equal to I squared, which simplifies down to a -1. Okay, if you ever have I squared, it's equal to a -1. All right. So if we go to this next problem, I'm going to change it. It's going to become 3i times 2i. So we multiply the real time, like numbers by numbers, i's times i's. So 3 times 2 is 6. I times I is I squared. Okay. We can simplify further though, because we know I squared is really 6. Oops, not 6 times I. 6 times -1, because I squared is -1, which gives us -6. All right. So that's really one of the things that comes in when you multiply complex numbers. If you multiply I times I, that's obviously I squared, but I squared simplifies to a -1, so 6i squared becomes -6. With that being said, we'll continue. So, if we have 2i times the quantity 4i plus 7, we know we must distribute this into our parentheses. So 2i times 4i is 8i squared plus 14i, which simplifies further to become -8, because it's 8i squared plus 14i. We realize that the real part's first, imaginary second, so we're good to go. All right, again, the rules of multiplication aren't changing. It's just they're getting a little different, because when you multiply i's together, it becomes I squared, but I squared becomes -1, and it kind of just changes some stuff. So if you looked at this problem, we must FOIL. So it's 3 times -2i, 3 times 5, gives us -6i plus 15. Then 2i times -2i is -4i squared. 2i times 5 is plus 10i. All right. Again, we must simplify this, though. -6i stays -6i. 15 stays 15. -4i squared becomes plus 4. And then 10i stays 10i. Now we got to combine like terms. Right? We know that -6i plus 10i is 4i. 15 plus 4 is 19. The only thing we notice here is that when you write a complex number in its final solution, you must put the real part first. So the 19 has to come first, and then plus 4i. All right, so it's 19 plus 4i. Any question on this? Let me know. It's pretty straightforward. Well, the next thing we're going to get into is dividing complex numbers. Okay, well, just like when we talked about radicals. Okay, if you have the radical of 2 over radical 5, this isn't allowed because you can't have radicals on the denominator. Likewise, you can't have imaginary numbers on the denominator. So all you do is multiply by the conjugate. Okay? When we're talking about conjugates of imaginary numbers, just multiply top and bottom by the negation of this. So if it's a positive 2i on the bottom, multiply it by -2i. Okay? So 5 times -2i becomes -10i. 2i times -2i becomes -4i squared, which will simplify to -10i over 4, which simplifies to -5i over 2. Okay? All you do is multiply the top and bottom by the conjugate. For this instance, it's just the -2i. And I'll simplify to that, which is pretty good. Okay? But then it gets a little trickier, because here we have 4i divided by 3 minus I. Right? what you want to do here is, again, we have to multiply by the conjugate, but since the denominator isn't just like a 2i, it's 3 minus 3i, the conjugate becomes 3 plus 3i. Okay? Basically, you just keep everything the same, but make the imaginary part the opposite sign. Since it was a minus 3i, it becomes a plus 3i. And you just multiply. So the numerator is going to become 4i times 3 is 12i, plus 4i times 3i is 12i squared, over. We're going to have to FOIL this out. 3 times 3 is 9. 3 times 3i is 9i. Negative 3i times 3 is minus 9i. Negative 3 times positive 3i is minus 9i squared. Now all you do is simplify. So we know that 9i minus 9i cancels. This becomes 12i minus 12, because the I squared becomes negative 1, over 9 plus 9, because negative 9i squared is negative 1 times negative 9, which gives us this, which we can further simplify to be 12i, or actually I'll just rewrite that. It's going to be negative 12 plus 12i, because we have to write it real number coming first, divided by 18. We can divide everything by a 6. You get negative 2 plus 2i over 3. Again, it gets tricky because there's a lot of algebra, there's a lot of simplifying, okay? But the main thing you have to remember is that you can't have an imaginary number on the denominator. So to get rid of it, you multiply by the conjugate, which you just multiply by the same thing, except make the imaginary part the opposite sign. Okay? Then simplify. So what I'll do is I'll do one more here. We have 7 over 1 plus 5i. Again, we can't have the imaginary down there, so we must multiply by 1 minus 5i. Just multiply both by the conjugate. Okay? So the top we're just going to distribute. So you get 7 minus 35i over 1 times 1 is 1. 1 times negative 5i is negative 5i. 5i times 1 is positive 5i. 5i times negative 5i is minus 25i squared. To simplify, we're going to get 7 minus 30. I'll erase that. 7 minus 35i over. These cancel. This becomes positive 25 plus 1 is 26. So your final answer is 7 minus 35i over 26. Again, it's nothing too crazy because you're just really multiplying by conjugates and stuff, but the algebra is what gets tricky. Remember that you combine like terms, you can only add and subtract reals by reals, imaginary by imaginary numbers. If you have an I squared, it becomes negative 1. And remember that reals numbers have to come first. All right, if you have any questions, let me know. Again, none of this stuff's too crazy. Hopefully it made sense to you. If you have questions, check out the other videos. Email me. Come see me. Try some of the problems. Have a good one.